Good afternoon, everyone. On behalf of the IEEE Vehicular Technology Society UK and Ireland chapter, I warmly welcome you to today's distinguished lecture, part of our 2025 series on AI, autonomy, and emerging trends in vehicular technology. I am Dr. Riazul-Islam from the University of Aberdeen, and I have the pleasure of serving as the chair of the IEEE VTS UK and Ireland chapter. I'll be moderating today's session. First, a quick note. This session is being recorded, and the recording will be made available through appropriate media channels. This way, you, as well as the members of the wider community and public, can revisit the session later. I would also like to acknowledge and sincerely thank my colleagues from the chapter, especially our Vice Chair, Dr. Tianjie from the University of Nottingham, and Secretary Dr. Ashraf Mahmud from the University of the West of Scotland for their continued support, along with all our well-wishers who help make this event possible. It's now my great pleasure to introduce our distinguished lecturer, Dr. Xingqin, 3GPP lead at NVIDIA and a leading global expert in wireless technologies. Dr. Lin has made major contributions to 5G and 6G standardization and is a respected author, researcher, and innovator with over 100 journal publications, 10,000 citations, and 200 plus patents. Today, he will present the interplay between artificial intelligence and 5G Advanced towards 6G. We kindly ask attendees to hold your questions until the Q&A session, which will follow the talk. With that, I'll now hand the floor over to Dr. Lin. Please go ahead.
Very kind introduction. Today I'll be talking about the role of artificial intelligence in the evolution from 5G Advanced to 6G. I always enjoy interactive discussions, so please feel free to jump in with any questions you might have. I'll do my best to answer as many as possible. So let's get started. Let's take a look at what we'll cover today. So we'll start by looking at some big trends happening in our telecom industry. Then I walk you through the latest updates from 3GPP on 5G Advanced and 6G standardization, especially what's happening in release 19 and what's coming in release 20. And next, we'll dive into how AI is being integrated into this 5G evolution in 3GPP. And after that, we'll be talking about a very exciting topic, generative artificial intelligence, especially large language models, and see how they can unlock new opportunities for our telecom industry. Finally, I'll wrap up things with a few key takeaways. And also, I will provide some pointers for further reading if you're interested. So let's start with a quick overview of some of the major trends that are happening in our telecom industry. So we know that across many industries, we are now seeing some pretty massive transformations. Now we see AI, cloud computing, and 5G are really starting to converge. And altogether, they are opening up all kinds of opportunities for both business and society. But as we hit the limits of traditional computing and Moore's law, accelerated computing has stepped in to fill the gap, both on the infrastructure side and also for new applications. So in order to meet the performance and functionality we are seeing today, we need accelerated compute. And also beyond that, we need to move AI from the cloud to the edge into smart devices and billions of connected things. So these devices are now spread throughout the network. So where does 5G fit in? Well, A truly ubiquitous 5G network is the glue that connects all of these, tying together data centers and intelligent devices with the right performance for the application. As mobile networks evolve, especially with 5G deployments happening around the globe nowadays, they are getting more and more complex. And we're seeing all kinds of new deployment scenarios and applications, and that's making these systems even more sophisticated. So to keep up and really to push things forward, we need powerful computing platforms that can support things like simulation, AI, and data analytics, all working together. That's where NVIDIA comes into the picture. So at NVIDIA, we have built several platforms to help researchers and developers innovate across 5G to 6G journey. You may be aware of we have so-called NVIDIA Aerial. This is a full range stack accelerated by CUDA. So it's a software-defined, which means it's flexible and programmable, which is perfect for real-time testing and development of 6G networks. And then we have AI radio framework. So this framework let you integrate seamlessly with popular tools like PyTorch and TensorFlow. So it uses GPU to handle everything from data preparation to model training at scale. This also includes Shana. Some of you may be aware of Shana, which is very popular nowadays, especially in academic research. So Shana is our advanced simulation library designed for AI/ML-based wireless research. Last but not least, we have Aerial Omniverse Digital Twin. So this tool gives you a physically accurate simulation environment from a single cell tower to an entire city. So it combines software-defined RAN and user equipment simulators with realistic terrain and environment modeling. We are in the middle of 5G advanced evolution, and now we are also starting to work on 6G standardization. So you might be wondering, how exactly does our industry go from an idea to an actual new generation of technology? This is what we call the wireless innovation cycle. And this cycle usually spans about 1 decade. So this cycle starts with a vision. What could this new generation do? What use cases should we support? And what kind of performance or capabilities do we want? So from there, researchers, both in industry and academia, start exploring potential technologies that could make that vision real. Next, we move into so-called proof of concept phase. So in this phase, companies build and showcase early prototypes at major events like MWC Barcelona. So once the industry starts to converge on what the next generation should look like, then the standardization process begins. So this is very essential in our industry because everything has to work together across vendors, devices, and networks. After we set the global standards, we move to the field trials and then to commercial deployments by mobile operators. So this is a long but very carefully coordinated process that's being refined over decades. So speaking of global standards, 3GPP is really at the heart of mobile innovation. What is 3GPP? It stands for the Third Generation Partnership Project. That it's the main international body responsible for developing or maintaining mobile communication standards. It's been shaping everything from 2G to 5G and now the upcoming 6G as well. So 3GPP really provides a complete system blueprint for mobile networks, including radio access, core networks, and service features. So the specifications by 3GPP are very detailed and globally interoperable. And in fact, most of the mobile technology we rely on every day is built on 3GPP standards. So next, let's take a closer look at 5G advanced evolution in 3GPP. Let's start with this overview picture and see how 5G has evolved over time. We know that 3GPP released the first official 5G specification in release 15 back in June 2018. That set the foundation for global 5G deployments. Since then, we've seen a continued development through release 16 and release 17, which added new features and supported more use cases. Then we had release 18. So that was approved at the end of 2021. So that really marked the beginning of what we now call 5G Advanced. So fast forward to December 2023, 3GPP approved the Release 19 work package, which represented the second phase of 5G Advanced. So in June 2025, just 2 weeks ago, in fact, 3GPP approved the Release 20 work package. So this Release 20 will be the last major release of 5G Advanced and the first major release of 6G studies. So that's where we are today. So before we talk or embark on the journey of Release 20, it's useful to look at what's included in the ongoing Release 19, which will be completed very quickly. So you can see this Release 19 package is very diverse, but also very focused. Each item is chosen to improve performance, enable new use cases, or help set the stage for 6G. So we can break these items into 5 main categories according to this slide. So first, we have network performance enhancements. So that includes things like better MIMO, improved mobility, non-overlapping sub-band 4 duplex, and also upgrades for XR applications. The second category is all about AI integration, which we will talk more in the upcoming slides. So there's having a very big emphasis on AI across the stack, including AI for the interface, AI for mobility management, and AI for 5G architecture, and also updates from the self-organizing networks and minimization of drive test perspective. In the third basket here, we have topology enhancements. So here we are seeing new work on 5G femto cells, wireless access and backhauling, silent communication, and support for non-terrestrial networks, especially satellite communication. In the fourth category, which is related to energy efficiency, this includes initiative to reduce energy consumption, such as low power wake-up signals, ambient IoT, and other network energy saving technologies. Last but not the least, we have channel modeling items. So these are studies to improve channel models for integrated sensing and communication, and also for the so-called FR3 spectrum. In other words, the spectrum between 7 to 24 gigahertz. So these are very important for 6G planning. I think people have been asking the question, what will 6G be for quite some times? And this has been also a topic for speculation for a while, but at the end of 2023, we finally got some industry-wide consensus. You might have seen these two pictures in other channels already. So in short, these two pictures are from ITU Working Party 5D, especially at the end of 2023, they published a document known as IMT 2030 framework. So this document lays out the high-level vision and serve as a reference for organizations like the GPP as they begin 6G standardization work. I think the most important thing from this picture is that we can see 6G really target 6 usage scenarios, including 3 that build upon what we already have in 5G. So enhanced mobile broadband, known as eMBB, evolves into immersive communication. MMTC becomes massive communication, and URLC expands into hyper-reliable, low latency. What's more important is that we will have 3 new scenarios known as ubiquitous connectivity, AI communication, and integrated sensing and communication. And this slide shows a potential roadmap for how we get from 5G to 6G in 3GPP. So we are expecting 6G to be commercialized around 2030. So working backwards from 2030, it's clear now it is the time to get started. So there's a real sense of urgency to start preparing in the telecom industry. So right now, 3GPP has already started discussing 6G use cases and requirements. That's the first step. And starting in release 20, in fact, in August later this year, 3GPP will start technical studies focused specifically on 6G. Then in release 21, we'll see the first set of 6G specification that will become the foundation of 6G deployment. So here's a closer look at what's coming in 3GPP release 20, which will be the main focus of the next 2 years. So think of release 20 as the bridge between two generations of mobile technology. On one side, it continues the evolution of 5G-Advanced, refining the technology in order to meet the ongoing commercial needs. At the same time, release 20 will also begin laying the foundation for 6G with very detailed studies and evaluations of new capabilities that will eventually become standards in release 21. So it's really a dual focus release, improving what we have today, also planting the seeds for what's coming next. So while release 20 continues 5G advanced evolution, it also plays a big role in shaping what comes next, as we just discussed. So some of the key technologies like advanced AI ML, massive MIMO, tighter integration between terrestrial and non-terrestrial networks, and also energy-saving features are all early stepping stones for 6G. Meanwhile, 3GPP is also kicking off two important 6G studies in this release. One on 6G scenario and performance requirements, another on the 6G radio design aspects, aiming to develop a non-backward compatible radio access technology in order to address the new scenarios and requirements in 6G. So these studies are important because they will lay the foundation for developing the 6G specification in release 21. So next, let's zoom in on one of the most exciting areas, how AI is being integrated into 5G advanced evolution and how that might impact 6G. So this slide gives you a snapshot of the AI ML related work in 3GPP release 18. You can see the effort spans across multiple 3GPP groups, from service and system aspects to the radio access network. So this is a pretty broad initiative. So one key area is the study on using AI ML for the 5G interface. That's where we are going to focus next. So this AI for interface study, the idea is to explore how we can enhance the interface by making it AI assisted. In other words, making it easier to support AI-based algorithms that could boost performance in 5G. Of course, what better performance means here depend on the use case. It could be higher throughput or more robustness, better accuracy, or improved reliability. So 3GPP started by selecting a few key use cases to study in depth. And then the goal is to eventually define a common AI framework, including architecture level functional requirements. So all of this work, defining frameworks, identifying improvement areas, evaluating performance, and even aligning on terminology across the industry, will shape the specification path for bringing AI into air interface in a meaningful, standardized way. So earlier, we mentioned that 3GPP started by looking at some specific use cases to understand the impact in terms of performance, complexity, and what changes will be needed when it comes to standards. So far, the main use cases being looked at include channel state information, feedback, beam management, and positioning. So for CSI feedback, the objective here is to reduce overhead, improve accuracy, and predict channel conditions more effectively. When it comes to beam management, here we're looking at things like predicting beam direction over time or space to reduce latency and overhead. And for positioning, the focus is on improving location accuracy especially in tough scenarios like when signals are bouncing around due to non-line of sight conditions. So let's zoom in on one of these use cases, CSI compression. This is important because massive MIMO is a key part of 5G. We know that massive MIMO uses a large number of antennas, and it's been a great success in commercial deployments, but still there's plenty of room to make it better. So due to the challenge in CSI feedback, 3GPP selected CSI feedback as one key use case to study how AI/ML can improve the air interface. So the idea is that we can use AI, specifically autoencoders, in CSI feedback, especially for FDD deployments where we don't have a channel reciprocity. In this case, the UE estimates the downlink channel, compress it, and then sends a compressed report back to the base station. So here's where autoencoders come into the picture. The basic idea is that you take the input, in this case, the channel matrix, compress it using a neural network encoder into a smaller, more efficient representation, and then transmit the compressed version to the base station. And finally, reconstruct the original channel state at the base station using a matching decoder. So you can see, in this case, we have a model that is split between the two sides, device side and base station side. So now we have to think of how they can be trained and managed together. So this really creates new challenges around model training, synchronization, and interoperability when it comes to practical deployment. So one challenge, as we mentioned, is training. If we use this autoencoder-based setup, the device and base station both need to run neural networks that are compatible. But here's the catch. The base station cannot realistically have a separate decoder for every device vendor's encoder, and vice versa. Device cannot carry encoders depending on which vendor's base station they are talking to. So the question is, how do we train and deploy a model like this so that the model work across vendors? So that's really an open challenge still being actively discussed in 3GPP. So solving this issue is going to be key for practical deployment of AI-powered CSI feedback, and also really lay the foundation for other two-sided AI use cases in mobile communication. So this slide shows a few different ways how we could train an autoencoder-based model for CSI feedback. So starting on the left, we have joint training at a single place. So in this case, all done in one training session. In the middle, we have joint training split across the device and the base station, but still done in one loop. So the encoder lives on the device side and the decoder on the base station side, but they are trained together by exchanging data back and forth. So you can see this is more complicated, but everything still stays in sync during training. On the right, we have so-called separate training on each side, but they are now done in different sessions. The training are not done together, but there still needs to be some coordination so that the models can work together in practice. For example, you could start with the device side, train the encoder, and then share a dataset consisting of the encoder's outputs and corresponding CSI targets with the base station. And then the base station can use that data to train its decoder. As you could imagine, each of these options has pros and cons. Some are easier to manage, but others may offer more flexibility. So nonetheless, it looks like a separate training appears to be most practical when it comes to actual development and deployment. Another CSI-related use case is CSI prediction. So one of the challenges with today's CSI reporting is known as CSI aging. So basically, there's a delay between when the device estimates the channel and when the base station actually gets the CSI report. So that delay means the channel information might already be outdated by the time it is used. So that is a real issue. So what can we do? One solution is to predict CSI ahead of time using AI/ML techniques. So by doing that, the base station gets a better idea of what the channel will look like when it actually needs to use it. So in contrast to CSI compression, which requires coordination between the device and base station, CSI prediction can be done with a one-sided model. So here we feed in a sequence of past CSI measurements and then train a model to predict the CSI at some further point in time. So here the training can be done either by a single vendor and only by one side, either the base station or the device. And only one side need to run the model at inference time. So this, from standardization perspective or from development deployment perspective, this is much easier compared to two-sided models. The other use case we mentioned at the beginning is beam management. We know that 5G supports a wide range of frequencies from sub-6 gigahertz all the way to millimeter wave. To make that work, 5G uses so-called beam-based design, where both the base station and device can use beamforming to communicate. So the basic idea behind beam management is to find and maintain the best transmit-receive beam pair between the base station and the device. So to do that, the traditional approach is that the base station sends out reference signals on each of its beams. Then the device listens, measures signal strength like ISRP for each of these beams, and then figure out which beam pair gives the best performance. So you can see this traditional approach is quite cumbersome. It involves lots of sweeping, and that comes with a pretty high overhead and also latency. So that's where AI/ML can help by using it to predict the best beam in advance, either over time or in different spatial scenarios. So that really helps reduce overhead and improve how quickly and accurately we can find the best beam pair. So let's take a closer look at how AI/ML can help with beam management. So right now in 3GPP, there are two main ideas being explored. One is beam prediction in the spatial domain, and the other is beam prediction in the time domain. So for the spatial case, the idea is pretty straightforward. Instead of the UE scanning and measuring every single beam, now it only measures a subset of the beams. So with that, it feeds those results into an AI/ML model, which then predicts the best beam from the full set. In the time domain case, the model uses historical beam measurements to predict the best beam for the current or future time. For example, the UE might have data from a set of beams over time, and the model uses that to predict the best beam in another set. The last use case 3GPP is looking into in this AI/ML for interface study is positioning. So we know that positioning is very important for many applications, from navigation to location-based services and also industrial automation. When it comes to positioning, we know that typically there are two main steps in figuring out the location of a device. The first step is so-called signal measurements. So this includes signals either from terrestrial like 5G network and also some other sources like GPS. And then in the second step, we can do position estimation. So this is where we take those measurements and solve a system of nonlinear equation to estimate the UE's location. So today's positioning technique are mostly geometry-based, meaning that we need to have clear line of sight signal paths. But in real world environments like urban canyons or indoors, line of sight is not always available. So in those tricky conditions, it's easy to confuse noise or reflections for a line of sight path. And also the presence of multipath can make it hard to tell which signals came directly and which bounce around. So AI/ML has a good potential to improve positioning accuracy, especially in the challenging environments we just talked about. So 3GPP have been looking at two main approaches for positioning. One is so-called direct AI/ML-based positioning. So in this case, the model takes in some signal measurements and then outputs the position estimate. In the second case, we have so-called AI/ML assisted positioning. So here, in this case, the model is used to generate some intermediate metrics like classifying whether a signal path is line of sight or non-line of sight, estimating signal timing, or measuring angles. So these outputs are then passed into a separate algorithm, which could be AI-based or not, to calculate the final position. So both approaches have been actively studied and specified to see how AI can really fill the gaps when traditional methods fail. All right, now we have discussed about how AI is being integrated into 5G advanced evolution. Next, let's look at a new topic that's getting lots of attention across industries, that is Gen AI, especially in the context of 6G. So when we talk about Gen AI, we are not just talking about one kind of model. There are several different types of Gen AI models that have been used in our communication problems. So this slide provides some of these Gen AI models like variational autoencoders, generative adversarial networks, normalizing flows, diffusion models, and of course, transformer-based models like the ones used in large language models. So each of these models has strength in different areas, and researchers are studying how we can use them in communication tasks. Now we know that Gen AI has really taken off, right? It gives us the ability to create content quickly using all kinds of inputs and outputs like text, image, audio, animation, 3D models, you name it. So a very significant turning point came in November 2022 when OpenAI launched ChatGPT. So that was the most advanced AI chatbot at that time. So that launch sparked an explosion of interest in Gen AI tools across industries, from answering customer questions to helping researchers accelerate scientific discoveries. Gen AI is now being used to boost productivity and also unlock new capabilities across the industry. So what we are witnessing with Gen AI right now really feels like an iPhone moment, a major technology shift that's changing how we work, how we create, and how we interact with information. So companies are now racing to adopt it. Large language models are being used to handle complex queries, cutting down the time we spend searching for or compiling data manually. And telecom is no different. So in telecom, Gen AI is already being used for customer support, synthetic data generation, user behavior analysis, and network prediction. But still, we are still in early days. It's a very exciting space with tons of potential, and I believe we are going to see some big advances in the next few years. So speaking of telecom, we know that for quite some time, telcos have really struggled to grow revenue beyond basic connectivity. So now the question is, do we want to stay just as connectivity providers or evolve into technology service providers? So we believe that with the rise of Gen AI, the opportunity is clear, and we are very happy to see many telecom operators stepping up. In fact, telcos are among the earliest adopters of Gen AI. The first areas they are targeting are usually customer care and network operations. Makes sense because both involve repetitive tasks that Gen AI can really help automate and optimize. We are also seeing telcos begin to offer Gen AI as a service, and they're actually very well positioned to do so because of their expertise in managing large-scale infrastructure. And we see operators are starting to build and running AI factories, centralized platforms for developing and deploying AI across the network. So at NVIDIA, we are working closely with partners across the ecosystem to support telecoms move toward Gen AI. So in this short video, you will see some examples how Gen AI is being used in telecom. Everything from customer experience improvement to intelligent network operations. Okay, I hope you enjoyed the video. So in the video, we're seeing many use cases. So the next question is, how can we really support Gen AI at scale in telecom networks? The answer is AI RAN, in our opinion. So AI RAN is maybe some of you may have already heard about AI RAN in the past 2 years. So AI RAN is all about turning the radio access network from a traditional communication system into a smart compute power platform that can support AI workloads directly. So there are three key concepts here. The first is AI for RAN. This is about using AI to optimize network performance. Then the second is AI on RAN. This is about optimizing radio access network to better support AI applications. And then last but not the least, we have AI and RAN. This is about sharing compute resources between AI and RAN functions. So by collocating AI and RAN workloads on the same infrastructure, AI RAN allows real-time inference, faster response times, and more reliable services. And also for operators, it means they can offer Gen AI as a service to both consumers and enterprise, while also making the best use of their hardware. So this slide shows how we can turn the data, we can design this data center, use a software-defined accelerated platform, all with a standard off-the-shelf servers. So these servers use powerful combinations of CPU, GPU, and DPU, which give us the flexibility to run both the radio access and core network functions on the same infrastructure. And meanwhile, this same platform can be used to support Gen AI and large language model workloads. So by doing so, we can dynamically share resources between based on what each workload needs. And then with proper orchestration, we can run AI and network functions side by side efficiently using the compute power without wasting capacity. So in this slide, we show some numbers to see why we need accelerated computing. When we offload compute-heavy tasks to accelerated hardware, not only do we see better performance for network functions, but also we get improved energy efficiency, which is very important for telcos. So this slide compares three different compute setups. The baseline is standard x86 CPU-only setup. Then in the second setup, we add a GPU accelerator, specifically NVIDIA AX800 converger card. And then the third uses Grace Hopper 200 platform. So in this case, we combine a ARM CPU and a GPU in a integrated system. As you can see, both the VRAM throughput and energy efficiency improve significantly. And on top of that, large language model performance also get a major boost. Now we have already discussed the infrastructure, but hardware itself is not sufficient for successful AI deployment. There are other factors we need to consider. First, enterprise needs to identify the right use case, something aligned with their business objectives and their internal priorities. And then comes data, right? You need good quality data, a clear understanding of your data sources, and also have consistent formats for the data. You also need skilled people, IT teams, data scientists, machine learning engineers, all working together. And finally, you also need a solid AI governance. That means building responsible AI systems that respect privacy, fairness, and transparency. So yes, it's a lot to handle. That's why we built NVIDIA NeMo. NeMo is an end-to-end platform designed to simplify enterprise Gen AI development. It helps organizations build and deploy customized large language models without having to reinvent the wheel. So with NeMo, you get tools for everything from data preparation to training and deployment. So it becomes easier to create AI applications tailored to your needs. So let's look at a concrete example, building an AI chatbot for telecom. So we know that we have foundation models. These foundation models are pre-trained and they're pre-trained on huge data sets. But for telco-specific use cases, that is not sufficient. You need to feed the models with domain-specific or enterprise-specific data. So how do we do that? So that's where retrieval augmented generation, known as RAG, comes into picture. So the basic idea is that instead of asking the LLM a question, hoping it knows the answer, you first retrieve relevant context from some internal knowledge database, and then pass that context along with the query to the model. So in this way, the model responds not just with what it knows from the training, but also using the real-time trusted enterprise data. So in the past few years, RAG has become incredibly popular, especially for enterprise application. So at NVIDIA, we also built a RAG chatbot workflow to help developers build this kind of applications quickly. So this slide walks through what a typical RAG pipeline looks like. So it has two main parts: offline document ingestion and online query plus response generation. So in the first phase, we load documents from different sources into the RAG system. Then we pre-process these documents, for example, breaking up long text into smaller chunks so that it fits nicely with the embedding model. Next, we generate embeddings, which means we turn the text into numerical vectors that captures its meaning. So these vectors are then stored in a vector database. So when a user submits a query, that query also gets embedded using the same model. The system compares it with the stored document vectors to find the most relevant content. Then finally, the LLM uses that retrieved context along with the original query to generate a more accurate and grounded response. So this slide goes a little deeper into how RAG actually works behind the scene. We can skip this slide. Okay, so a common question is people often ask is how is RAG different from fine-tuning? So fine-tuning means that you can take a pre-trained large language model and then retrain it on your own domain-specific data. So this provides very high accuracy, but it's also resource-heavy and time-consuming. And then we have parameter-efficient fine-tuning. So this is a lighter version. You only update part of the model, which saves the resources but still boosts performance. Then we have prompt engineering. Prompt engineering doesn't change the model. You just craft better prompts to guide the model's output. So this is the easiest and also least expensive way to tailor the model's behavior. So when it comes to RAG, you can think of it like a supercharged prompt engineering. It brings in external knowledge to add context to your query before the LLM answers your prompt. So these are not either or techniques. You can and often should use them together depending on your application needs. So a good strategy, I would say, is to start with RAG and to quickly improve your model output relevance. And then you can move on to fine-tuning or parameter-efficient fine-tuning if you need more domain accuracy. So here's a real-world example, a RAG-based AI chatbot for all-round standards. This example was also quickly shown in the video you just saw a couple minutes ago. So using RAG, we're able to provide current accurate information to the large language model so that users can get more trustworthy answers, better experiences, and fewer hallucinations. So in this example, we ingest the all-round specifications into the chatbot, and the users can ask natural language questions. Then the chatbot can explain technical details, provide examples, and even point to relevant specifications. So we have made this chatbot open source and publicly available on GitHub. So if you're interested, you can try the chatbot. Let's look at some numbers about evaluating chatbots. Evaluating chatbot is not trivial. In fact, it's quite tricky because the expectations are often very broad and not always clearly defined. So that's why the community has increasingly turned to a method called LLM as a judge, where you use one LLM to evaluate the outputs of other LLMs. So we did something similar here to compare different RAG setups using GPT-4 to judge the quality of responses. So the key takeaway from this slide is that even very basic rack, what we call vanilla rack on this slide, performs significantly better than having no rack at all. And if you can build more advanced rack, that can improve the performance even further. Okay, let's wrap up our Gen AI discussion with this slide. So this slide outlines the typical life cycle of building Gen AI for telecom. So many people, many teams start with cloud-based services that use general purpose large language models. So those are great starting points for quick experimentation, but they are not trained on telecom specific data. If we want to build more useful Gen AI application for telecom, we need to infuse those models with domain-specific knowledge. That's where RAG comes into picture. So with RAG, we can connect large language models with external sources of telecom data, making the responses more accurate and reliable. Okay, now we are almost at the end of the presentation. Let's just to leave you with a few final thoughts. So 5G Advanced is the next major step in 5G development. And the work in release 19 and also the upcoming release 20 will lay the foundation for 6G. So now we have this once in a decade opportunity to design 6G. We have an opportunity to design AI native networks, networks that are built to leverage data and AI from the cloud through the core network and to the radio access network and all the way to the devices. So along this way, telcos are already adopting Gen AI for use cases like chatbots for customer support and also intelligent network management. And that is just the beginning. So we have covered a lot today, and we only scratched the surface on many of these topics. If you'd like to go deeper, check out my recent article on 5G Advanced and 6G in 3GPP Release 20. And also please consider joining NVIDIA 6G Developer Program to get access to tools, software, and hardware for 6G innovation. So that brings me to the end of this presentation. Thanks so much for your time and attention. I'd love to hear your questions or thoughts. Thank you.
Thank you, Dr. Lin, for this very fascinating and thought-provoking lecture. So we can now move to the Q&A segment. So please feel free to ask question or raise your hand or post your question in the chat. I'll do my best to relay them to Dr. Lin. So let's begin our discussion.
Should I go ahead?
Yes, Shahzad, please.
Hi, riazul.islam, and hi, Mr. Lin. Thank you very much for such a great presentation. It covers a lot of interesting topics. So I have a quick question. On one of the slides, you did mention, I'm from University of Aberdeen, by the way, so I should introduce myself as well. So in terms of one of the slides, you mentioned autoencoder-based CSI compression. Is there any specific reason you choose to use autoencoder as a compression technique compared to other traditional compression techniques like PCA-based techniques?
Yeah, so I think autoencoder is just one example. In fact, you are not restricted to autoencoder, right? I think the key here is that you need a two-sided model. Whichever the technique is used, you need some encoder, some sort of compressor at the device side, and some sort of decoder or decompressor at the base station side, right? The key here is that how do you make them work in a compatible way? So from a practical deployment perspective, the base station doesn't care, okay, what the device use, whether it's autoencoder or something else. And the device doesn't care what the base station actually is using, right? The important thing is that how can we make these two sides interoperable? So from standard development perspective, standards usually don't mandate certain types of implementation. Here, I choose autoencoder just to illustrate the concept and to highlight the challenges we are facing in this type of applications.
Yeah, maybe at some point in terms of complexity, it might need some consideration. If the traffic and the data is too complex, maybe autoencoder might cause some delays. I'm not sure because, yeah, thank you very much for explanation. I appreciate that.
Right. Thank you, Shahzad. So next question, Ashraf, please.
Okay, thank you very much. Very exciting and very in-depth presentation. Thank you very much for Xingqin. My question is, I know that you are actually presenting the NEMO, so one of the great, I think, effort. Do you know this? The question is in terms of cost management and how university can use it, or how student can explore on that one. So this is one of the things, because at the moment, if we can think of DeepSeek, they are providing open source, and also they are not using your GPU or DPU. So in that case, they are using the old, graphics, and they are producing a much more good result. What is your comment on that? In particular, another point, I know I can finish it at one go. The AI is directing to the AGI. So in that case, whether we're reaching, I know the 6G will play a role, but at the same time, quantum computing is also will be playing the role. So in that case, for your company like NVIDIA, how do they think about in that direction or in that aspect? Thank you.
Yeah. Okay, let me address the question one by one. The first question is related to access to NEMO. I'm not a part of NEMO team, but if you have specific questions related to NEMO, you can send an email to me. I can direct those emails to NEMO teams to provide more information when it comes to access to NEMO tools, especially for academic like universities. Then the second question you're asking about the move from cloud AI to edge AI, right? Yes, certainly we are seeing this trend, and we believe that is very important. That's why we have been championing this AI RAN initiative in the telecom industry. So the idea of this AI RAN is that to transform this traditional communication infrastructure into a computing platform that can support both communication and AI workloads. So that's why you can support edge AI natively using AI RAN platform. So we do believe that's a major technology shift going forward. And the third one is related to quantum application and quantum communication, etc. I think you can find more details on our company position when it comes to quantum technology. I think our CEO Jensen has been talking about quantum in different venues. So when it comes to 6G, I could mention that although we don't see quantum communication in the near term when it comes to 6G, but at least there's one application in 6G when it comes to security. People have been discussing how to introduce quantum safe security technology in 6G so that we are prepared for the quantum era. Yeah.
Can you
hope I answer all your questions.
DeepSeek issue.
Oh, the DeepSeek issue.
Yes.
I think the DeepSeek issue, in fact, our tools and platforms are very are inclusive. You can see, in fact, NVIDIA has already included DeepSeek as part of our offering. You can check out those for more details. It's not like, okay, we are exclusive, right? In fact, DeepSeek is more like a model, and we are a platform. Our platform is designed to support any kinds of model you have, whether it's Llama, whether it is GPT, whether it is DeepSeek. They can all be deployed and supported in our platform.
Okay, great. So thank you. So the next question is Muhammad Atiq Rahman Ahad, please.
Hi, thank you very much indeed. A wonderful presentation. My name is MD Atiq Rahman Ahad. I am a professor of AI at University of East London, UK. So my question or query is that you have mentioned about generative AI, large language models. Definitely LLMs are playing important role in various areas, and some of the companies also, or this kind of LLM, producers, they also introduced some sort of LLM based or similar kind of things for the telecom industries, even NTT Docomo in Japan. So I'm from Japan, so that's the thing. So, but I would like to know if you a bit more that whether there is any large models specifically successful related to telecom industries, as well as towards a 6G, because we have large video models in the last couple of years, especially last 1 year. Lots of people are working on, and language models are there and vastly powerful. Is there anything like successful large 6G or 5G related or telecom related models which are successful?
Yeah, I think that's a very good question. I think in our communication society, there's an emerging technology initiative related to Gen AI, large language model. I think those efforts are being championed by some researchers from Middle East. They have been releasing some models, but I would say from a commercial success point of view, those models are still a bit far away from reality, I would say. So what I see, what's really useful when it comes to telecom is that you take a pre-trained, very well-established large language model like Llama or DeepSeek, right? And then you either apply some fine-tuning or you use some like RAG techniques we discussed in this presentation to make it useful for telecom. And in this, many of these efforts, I would say, they tend to be proprietary. Usually, they don't really make their applications or their models accessible to the general public. And I'm not aware of very successful, well-established open source telecom specific Gen AI models for 6G at this stage. So that's something the academia and the industry could work towards together in the coming years.
Yeah. So thank you very much. And another just quick point, like we know that NVIDIA offered and still has been offering various kinds of industry academia or NVIDIA academia collaborations by providing various kinds of GPUs and related things. For now, based on the current context, because it's a different world now, and American policy as well as perspective is different, and success of LLMs. Is there any option at this moment, or it's coming, that for researchers or for students, if we want to build a good lab regarding this kind of upcoming research issues, like large models, large fundamental models for telecom industries or others and others? Any kind of NVIDIA supports possible so that we can explore?
Yes. I think that really echoes well with my last slide here, right? If you look at the right part of this slide, it says this is a very recent blog, maybe 2 weeks ago, by one of my colleagues. So in this blog, you can see European researchers. In fact, many European, over 200 companies and universities in more than 30 European countries are using our platform to do the 6G research. And specific to your question about the support, I can show you. I can name one example. So NVIDIA has a program so-called academic grant program. So in that program, researchers can apply. So of course, we have call for proposals, right? There are certain topics we are more interested. So if I think researchers are more than welcome to submit proposals to apply for NVIDIA academic grant. So if the proposal is accepted, then the researchers will have access to NVIDIA resources, for example, like a free GPU access in order to support research in university. So we do have programs to support those kind of research. And also, please join 6G developer program. There you can also have access to 6G specific tools as well.
Okay. Thank you so much.
Great. Thank you. So thank you, Professor Dr. Ahad. And thanks for a great answer. So we also have, two questions in the chat box. So one from Nurila. So he's asking about how do you use the intersection of a natural language interface and network operation? Could we someday talk to network to reconfigure it?
Yeah. I think I would say we are not at that stage yet, but we are seeing a trend towards that stage. So now with these large language models and Gen AI in general, right, we are seeing the possibility coming up. Maybe you have noticed some of those use cases in the video I played during the presentation, right? And also now people are talking about like intent-based networking. Really, you just from customer or operator perspective, you just provide intent to your system, and then these some models, maybe some large language models, can translate this intent into network operation, management strategies, etc. So I would say we are not there yet, but we are having very good progress towards that. Yes.
Is that what you asked, Nurila?
Yeah. Thank you very much. Appreciate. Nice presentation.
Great. So we have other questions from Tarek. So he's asking that, is there any upcoming standard for AI-based beam management in high bandwidth like millimeter waves or terahertz? Will be a framework that integrates AI, ISAC for beam management improvement?
Yeah, I think that's a very relevant question. For the first question, in fact, that's being done in current 3GPP release 19. As I mentioned, in release 18, 3GPP started 3 use cases. One is AI ML for beam management. So that's specifically, in fact, for millimeter wave. So that was started in release 18, and now it's standardized in release 19. So to your first question, the answer is absolutely yes. And then regarding integrating AI and ISAC for beam management improvement, for the AI part, I already addressed that. For the ISAC, I would say that's also another very interesting usage scenario towards 6G. Now, in release 19, 3GPP started ISAC or develop channel models for ISAC. Now in release 20, for the first time, we will see some preliminary work on supporting ISAC when it comes to 5G Advanced, and we will see more in 6G. And then I would say at some point in future, it's not difficult to imagine that we will also, use not just ISAC, network for ISAC. That is, we use network base station to do sensing, for example, but we can also see the applications of using ISAC for network. That is, for example, you use some video or some sensing techniques to help you improve your network performance, for example, in beam management. So I would say at this stage, we are moving towards that. Although I would say there's nothing in standard preventing you from doing so already in practice. You can have a camera on your base station, right? And then you can use your camera to sense your surrounding environment and fuse those sensing results back to your base station algorithm in order to do a better beam management technique. So the short answer is that, yes, standard is moving towards that, but you can do so already today with proprietary solutions.
Great, thank you. So I hope that, Tarek, you got the detailed answer. So at this stage, I have one very naive question, and that is, you have, about, autonomous, vehicle, and there's you have like something called spoofing attack, and I'm very much worried, and many of us are worried about, that when these things will be really, intelligence and everything autonomous, then this kind of spoofing attack will be, I mean, everyday experiences. So on that aspect, is there any sorts of, particular discussions or any kind of strategy that from the either from the physical layer or from, let's say, from 3GPP, initiative, they can address this issue, that how, from the network perspectives, how they can play any roles to, work against these sorts of, spoofing attack?
Yeah. I think that's a very, very good question, right? Very relevant. So whenever we have new techniques popping up, people it's natural for our human beings to worry about the security aspects, and that's a natural concern. When it comes to network itself, I think people realize now we have a opportunity in 6G to really revisit some of our security technologies. For example, I mentioned quantum safe, right? Now we have this quantum computing. In order to make our network more secure, when we design security or security mechanism 6G, we need to make it more secure, to make it quantum compute resilient. And also people realize now let's in 5G networks, we have some messages in our network, like especially when it comes to access structure, radio access network, like layer 1 signaling, layer 2 signaling, they are not encrypted. So that also may increase the potential safety issue or security issue. Now people are really addressing these issues very seriously, and hopefully in 6G, we'll start to see a much more secure network. Yeah.
Good to hear. So the last one is very obvious that when comes this, let's say, this kind of 6G, we're moving to, we have how important the cross-industry collaborations, this important, particularly I'm talking about, let's say, AI companies, chip makers, and telecom operators, when they basically shape the standardization landscape. I mean, what's the, your present activities on that, when you are developing the standards and all those stuffs, what sort of collaboration going on among those?
I think that's a great question to wrap up this presentation. Yes. What I personally see in 5G times that our industry, when we design 5G system, we tend to come up with requirements by ourselves, right? We thought about the needs from vertical industries. Then we have requirements come up, like so-called UILC requirements. Then we design our system so hard in order to meet those requirements we are thought by ourselves. But unfortunately, one example is UILC, right? We make our layer 1 so ultra reliable, so low latency, and hopefully our intention in 5G was to support UILC applications. Unfortunately, the reality is that UILC was barely used and implemented in practical networks. That really brings us to a good lesson that in 6G, we should not design the system in silos, just based on our own thinking in telecom industry. We really need to welcome cross-industry collaboration. We need to listen to the real needs from, for example, vertical industries, from autonomous industries, from factory, from satellite industry, to really design our system to meet the actual needs of this industry. So back to your original question, yes, we strongly believe in cross-industry collaboration.
So thank you very much. So we are now at the end of our session. So as usual, on behalf of IEEE VTS Xingqin Ireland, I'd like to extend our heartfelt thanks to Dr. Xingqin Lin for sharing your deep expertise and visions on the intersections of AI and next generation wireless technologies. So as a token of appreciations, we would like to present a certificate. So let me share the screen for the moment. Can you see that?
Yeah. Thank you.
Yeah, I hope that you accept it. We'll send it over to you. It's just so simple, just from ourselves. So I hope that makes some sense. And now we go back to the event again.
Yeah, so, thank you for organizing this event. Yes.
So we'll send it, and thank you once again for everyone for attending, and we hope to welcome you for the future sessions that we will be organizing. And this is a part of our distinguished lecture series, so much more coming down the line. So thank you again. Have a great evening.
Thank you. The pleasure is mine. Have a nice rest of your day. Bye-bye.
Yes. Bye-bye,
Thank
everyone.
you. Bye-bye.
Yeah, see you.
Thank you very much. See you. Thank you, Professor Riaz, for arranging such a